Water is an extraordinary substance. We take it for granted because it's just everywhere. We drink it, we bathe in it, it's in the oceans, in the river. But it's actually a very unusual liquid, and it's essential to life. It has a low molar mass, and yet it's a liquid at room temperature. And that's due to the hydrogen bonding. It has very strong intermolecular forces for its size. It is the main solvent in living organisms. It's the solvent for most things in our environment is water. It has a very high specific heat capacity, and that causes it to moderate the climate. We looked at the temperature changes in San Francisco compared to Fresno. And then it expands when it freezes, and this is unusual. Most things get smaller when they freeze. Water gets larger. And because of that, ice cubes float. Lakes, when they freeze, do not freeze solid because as the surface of the water, where it's colder, freezes, the ice stays up on the surface and then helps to insulate the rest of the lake. If water was more, If ice was more dense than water, as the ice formed on the surface of the lake, it would sink to the bottom and the lake would freeze solid. And then all the fish would die. So that wouldn't be so good. The other thing that we see that happens because of water expanding when it freezes is things like this. You don't freeze lettuce on purpose because when you do, the water in the cells expands and breaks the cell membranes and kills the plant and just turns things like lettuce into mush, right? So that's why you don't go to the store, you don't buy frozen lettuce and then make a nice salad out of it because it doesn't work. That's why your tender plants in the winter, the frost comes and they just go and they die. We looked at this earlier, but here's another more detailed one looking at the boiling point as a function of the period in the periodic table. And we see period 4, and this is period 6, period 7, and period 5. And over here where we have no hydrogen bonding, we see a nice orderly trend here. But then when we get over here, these guys, water, hydrogen fluoride, and ammonia are way higher than they should be. Why is that? E.T. phone hole. Hydrogen bonding, yeah. Because here we have nitrogen, hydrogen. Here we have fluorine and hydrogen, oxygen and hydrogen. These all have hydrogen bonding because of that unusually strong intermolecular force that causes their boiling points to be significantly higher than what would be expected. Where does this chapter end? Good grief. Water pollution. I'm not going to test you on this. There's two main types of water pollution, biological and chemical. Biological contaminants, a lot of those you can take care of by boiling the water or putting chlorine in it. Chemical contaminants, much harder to get rid of. Boiling your water is not going to get rid of non-volatile chemical contaminants. You have to use some sort of a filter.
Would salt be chemical?
So, salt would be considered a chemical contaminant, yeah. You get salt in your water and then it's not good for drinking anymore. So, our drinking water is precious and we need to protect it. There we go.